Hey everybody, welcome to your measurements lecture. Let's jump right in. So the first thing I want to bring your attention is the English system of measurement. Now we use the English system of measurement almost exclusively in the United States, but almost everywhere else in the world uses SI units. So we have to be able to convert those things. If you look over on the right, we have a few conversions that you might want to keep on hand. Maybe take a screenshot of this to put in your digital lab notebook. Just to bring it to your attention and kind of show you what I'm talking about is a car's fuel efficiency is in miles per gallon, right? Your height is given in feet and inches. Ice cream is sold by the cup, the pint, or the gallon. Weight is in pounds and ounces. And of course, temperature in our English unit is Fahrenheit, but most people can't remember conversions like miles to feet or yards, right? So back to our English unit of conversion, or our English units of measure. The metric system, in contrast to that, is just a decimal system of measurement where basic units are used in conjunction with prefixes to represent multiple or fractions of a base unit. So because of the logic and simplicity, the metric system gained international acceptance with the Treaty of the Meter. Now, even the U.S. signed the treaty in 1875, but we really only use the metric system for liters of soda and the CCs and hospitals. And that's really it. That's all we actually use it for. Now, when we're talking about in science, the metric system is almost exclusively used. Okay, so most of the equipment and the instruments in a chemistry lab, especially the one that we're in here, generally measure in centi, milli, and grams. So in science, each lab that you do builds on each other, and this is especially true for chemistry. So you worked with both the metric system and the English systems when you converted units. So you're going to use an analytical balance and mass by difference to determine the masses of various samples. You're going to use a ruler and you're going to measure the dimensions and determine the volume and the density of a rectangle or a cylindrical solid. And then we can talk about reading graduated cylinders or anything of the sort. So accuracy and precision is really what science is all about. The primary goal of this experiment is to learn how to record measurements to the correct number of decimal places that's going to reflect the accuracy of the instrument used, right? So most of the credit of this experiment is going to be based on the accuracy and the proper number of decimal places. You have to keep in mind sig figs. If you're struggling with sig figs, make sure to go to the video library and check all those out. So we're going to the proper number of decimal places, remembering our sig figs, and we're going to record for measurements and the proper use of sig figs when those measurements are used in subsequent calculations. Okay, that's not going to be the only time you're going to see that slide, but in most chemistry labs, balances are used to determine the mass of samples. The metric unit of the mass is the gram. So you're going to be using electronic balances that are very expensive and very sensitive. And there are some rules that you need to know about the analytical balance, okay? So I'm gonna tell you what those are, and I would advise you to maybe put those rules into your lab notebook if you don't already have them. So the first thing we're gonna do is we're never gonna place any chemical directly on the balance pan. We're gonna use a beaker or watch glass or weigh boat or whatever the case may be, but we don't want to contaminate that balance. The second rule, all balance doors are supposed to be closed at all times unless you're loading and unloading. Now, some balances that you're going to use in our lab are not going to have doors on all sides. Just keep it in mind, if they do, they need to be closed. You want to make sure not to lean on that balance table. It's going to pick up your vibrations. It's going to cause your balance to bounce back and forth, and you're not going to get a clear reading. You're going to make sure to tear your container on the balance before you add your chemicals. And we'll get a little further into that in just a few minutes. Before weighing, we're going to be sure the side doors are closed and the displayed reads 0.000 grams, which is basically combining two of those other rules, right? We're leave the doors closed if they're supposed to be closed and tear before we add our chemicals. When reading the scale, make sure the numbers are stabilized. You're never going to round numbers. You will never round numbers coming off of an analytical balance. Okay, so let's talk about tearing. We're going to place an empty container in the center, and we're going to close the doors if our balance has doors. So on the front, you're going to press a T button or a tare button, which is where this finger is right here. We're going to remove the container from the balance and add the chemicals. We do not re-tare at that point. So you'll close the door and read the scale when it's actually stable. So that is taring in a nutshell. Okay. So for rulers, our basic unit of length is the meter. We usually measure chemistry in centimeters. So 1 meter equals 100 centimeters. That is something that should be common knowledge and you should know off the top of your head. So make sure you learn those. If you're struggling with those, just come to me and ask me, and you and I can come up with a plan for you to remember it really easily. Measurement is always recorded to 1 more decimal place than the smallest markings on the instrument. I will say this one more time. Measurement is always recorded to 1 more decimal place than the smallest markings on the instrument. Let me show you an example here. So this centimeter ruler has numbers marked for each centimeter, and then the 10 smaller markings between each number is 1 millimeter. On some rulers, the 0 centimeter mark is not at the end of the ruler, so the ruler is still accurate even if the ruler becomes rounded at the end. The length of an object is measured by placing the object at the 0 mark. The last digit has to be estimated. So this length is between 3.2 and 3.3, and the last digit is only estimated. It could be correct at 3.25 centimeters, at 3.24 centimeters, or even at 3.26 centimeters. Okay, let's talk about looking and reading a graduated cylinder. So the first thing that we're going to do is we know that our graduated cylinder, if we're, it should be sitting on the bench. We should not be holding and measuring a graduated cylinder. Okay, your eye has to be perpendicular to the bottom of the meniscus. And I've got a couple pictures coming up in just a second. It's going to show you the meniscus. So you read the bottom of the meniscus. If you view it from the top or the bottom, which is both incorrect, right? We're gonna cause something called parallax, which just means it's deceptive displacement. We're not going to get the right reading on it. But here is a meniscus, just to show you. Your graduated cylinders hold and deliver precise measured amounts of liquid. You should have a 10 mil and 100 mil graduated cylinder in your stations, but we have other sizes that are available. So for your greatest accuracy, you're going to use the smallest graduated cylinder that will hold your entire volume. It's got to be sitting on the counter, like I mentioned, and not held up to be accurate. Now, all graduations are read from the bottom up, and they indicate the volume contained in the cylinder. And if you look at this little dip, this little curve in the liquid that's in here, where it says mark reading here over on your right, that's your meniscus. And remember, we're reading in the center at the very bottom of it. And so that's where that actual reading is going to come from. So let's talk about burettes. Burettes are a special tool. They're used to deliver a recorded amount of liquid or a solution to another container. And they're marked in milliliters just like a graduated cylinder, but it shows 0 milliliters at the top. And the numbers increase as you go down the burette. And the stopcock, which you see on the right, that controls the liquid flow. It is open when it's parallel to the length of this burette, and so this is actually an open stopcock. If we put liquid into this burette, it will run right through that tip because that stopcock is open. So obviously, when the stopcock is closed, it's going to be turned perpendicular to the length of the burette. Now, in order to clean your burette, you're going to rinse it with DI water and let it run through the tip in the sink. Then you're going to condition it, and the way you're going to do that is you're going to use 5 to 10 milliliters. You don't have to measure it. This is a guesstimate, right, of the titrant, which your titrant is the solution you're going to put inside the burette. It could be anything. That's just what we're going to call it. Your titrant is going to be what is going in the burette. So you're going to tilt and roll the burette to rinse it and rinse the inner walls of it. Drain the solution through the tip. That's going to go in a waste container. We don't ever put chemicals down the drain. Okay. So then we want to fill it. We're going to make sure our stopcock is closed. We're going to use a clean funnel that should be in your station. We're going to place a container under a burette tip. We're going to open the stopcock to make sure there are no air bubbles. Your initial level does not need to be 0. Use the amount of titrate that you need for the titration. We don't want to waste any, right? So we always refill the burette before each trial to make sure that you have enough titrant to complete every trial that you do. Now, when we're done with it, we are going to clean it. And the way that we're doing that is we're going to empty the burette into the waste container. We're going to rinse it with DI water, roll it with our fingers again. You're going to do that twice, and you're going to rinse again with DI water and let it run through the tip. And when you let it run through the tip, you're going to leave the tip open so we can try to get it as dry as possible for our next student coming in to use it. So one more time, just to show you, our International System of Units. This is known as our SI units. Your metric system is used scientific community and known worldwide to reduce the need to convert from one system to another. So here are some things. Your mass is in kilograms or grams. Your temperature is in Kelvin. Your distance is in meters. Your volume, cubic meters. And your time, that's in seconds. So that's all I have for this particular lecture, for your measurements lecture. If you have questions, make sure to reach out to email to your instructor, and good luck.